Hello.
How you doing?
All right. How are you?
Good, good. It's been a minute.
Is there anybody else going to be on this? It looks like Dawn might not be able to make it for very long.
Yeah. And then at which point I think it's you, me, who else is confirmed?
I think that was it. Maybe PatCon?
Maybe PatCon. That would be good if Pat could join, but if not, that's fine. I mean, hey, there's Pat.
Hey, speak of PatCon.
Perfect. What's up, dude?
Hey, dude. PatCon with short hair.
Mm-hmm. Short hair PatCon.
It's cool these days.
Yeah, dude, do you know if we're getting anyone else today?
I don't, if you mean Dawn, I'm not sure. We haven't spoken today, so.
Yeah, she was saying at most she'd join for like 15 minutes. So that's fine. If anything, it was good motivation for me to get the repository cleaned up while that's at this point.
They just came out of nowhere.
Yeah. There's like, it's crazy. It's like making its way through a window in another building that's like across the way and then being just like, yeah, it's awful. Anyways, yeah. So yeah, if Dawn doesn't join, that's totally fine. We can walk through this and we have the recording. So it's something we could use later. Yeah. What do you think? Should we just start? What's the
I think that'd be fine.
I'm cool to wait 2 minutes. That's not going to be.
I'll at least go yell at the channels. Just not the link.
Pat, your background noise is really loud.
I know. I'm trying not to talk today.
Okay. Well, then I'm going to take that as why don't we just start? And we'll
Okay.
from there. Okay.
Yeah.
I guess the easiest way to do this is if I just share screen. Does that make sense?
Sure.
We can sort of talk through things, and as usual, you guys can ask questions, and we'll make sure.
If you do want to give me like 2 minutes, then I can drop the link in a few other places and just bombard. Yeah.
Sure. It's fun. I've been digging in on getting our Golang Works package to be fully interoperable with the Work.io Python package.
Wow.
It's Billy has written some really nice code. It's really easy to follow.
Cool. Very good. What is this code written in? It's probably not Go. Right?
It's Python. Yeah.
Oh, it's Python.
Yeah. If it was Go, I'd be done. Which would be great. But yeah, it sounds like I had beers with Ray and Dan Allen last night. Ray Cha, who has just joined he's joining Edgy. But yeah, they've apparently need to figure out a way to sort of parallel stream a whole bunch of requests into work files, and basically play them back and transform them into work files. So that's something that Go will do nice and quickly and nicely in parallel. And so if we can confirm that the package, that the tests are both passing and equivalent between the Work.io spec and ours, not spec, the Work.io tests and ours, I think we're in a good spot. Hopefully we can use that as a trial run. It'd be interesting.
Cool. Yeah, Work has a spec, right? Isn't it even an ISO spec?
It is, yeah. Actually, Work 1.0 and 1.1's in progress, but it's an ISO spec, yeah. So I read through that to start with, but the spec actually doesn't cover a whole bunch of things that are... Hey, Ray, what's up? Yeah, the spec doesn't cover a whole bunch of stuff that works need and use, because the spec basically says, hey, this is how work files work, but then there's a whole bunch of things that, like the Wayback Machine, will use and depend on that aren't in the spec that are actually very important. And so that's all covered in Ilya's really nice library. So if they match, we should be good. So, yeah. Anyways, you guys ready to jam? You want to do it? Okay, let's do it. Let me give you 1 second here. I'm going to share my screen. So yeah, I guess this will be a quick overview of the data together sort of architecture, and then a conversation about road mapping, next steps from there. So from here, I'm going to share my screen if that's cool. At any point, if you guys have questions, just interrupt me. I feel like it's probably best because if you have a question, there's probably someone listening to the recording who wants a question, who wants that same question asked. So please feel free to just interrupt me as I'm talking. I'm not going to be looking at the video screen, so just speaking about it. Cool. So I'm going to share my screen. Let's see if this works. Can everybody see this?
Yes.
Technical
I
roadmap
can.
and service overview.
Yes.
Awesome. 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 Okay, cool. Yeah, so I had a chance to update this repo today, and we're going to, I think, go through this. I've taken down some of the old graphics and brought it up to speed. I think we're going to cover a couple of basic things today, which is just like an overview of all of the stuff at our Data Together organization repository. So this is what that looks like when it decides to load. And everything that you're looking at here is in the roadmap repository, which will cover everything that we're talking about today. I think, yeah, there's a couple of things that would like to change. I'd like to sort of talk about in terms of how we organize the actual road mapping process, which we can talk about at the end. But first, I think I'll probably just start with an overview of like all the services, all the packages from a 10,000 foot perspective. And then I've gone through and written some notes on what all the sort of idiosyncrasies about a service and like how to go about investigating a service and understand what are some of the common patterns between them all, so that when you see a pattern in one place in one service, you can use it in another. So yeah, basically this, we did this really quick diagram that there's only really 4 groups of things that we need to worry about, and from the highest level perspective. Front-end services, it's basically anything that renders to a website. So we have 2 of those. Back-end services, which are custom services that we've written that are that sort of do things that Data Together needs done. Packages, which are specific things that are worth calling out that are pieces of code that get used all over the place. And then external services, which are just references to the types of any sort of other service that we're dependent on and using quite heavily. There are additional things that aren't covered by this diagram, but they're not really of note unless you're getting really deep on a very specific service or package or anything. Generally, all of this is oriented around a couple of key tasks that Data Together does. And if you want to learn more about what Data Together does, the website repository is probably the best place to start with the sort of technical principles, or not the sort of governing social principles that we're chasing. Anyways, I'm going to start with really quickly with the front-end services. This context service is probably the most important, the easiest entry point for the actual app itself, because that's the bit that everybody sees and touches. That's a web app written in React and Redux, and that's available at datatogether/context. Oh yeah, and for reference, at the very bottom of this README is a list of everything that's in that services with a link to its actual GitHub page. Although they're all Data Together, except for some of the, like obviously RabbitMQ and IPFS are not Data Together services, but they do link to the respective places. And so the context is a web app that all of these services, it basically makes use of a lot of these things in one way or another, and is the sort of face of the whole thing. So if you want to get started with Data Together, the best place to start is actually with the context repository. And I've included a note on running Data Together platform locally, which sort of outlines exactly this. If you want to get started, the best way to do it is, because all of our services are containerized, is to clone that repository. And there's a Docker Compose file in there. And you can type something called Docker Compose up, which all of this is outlined in the actual README for the context repository. This last step here, Docker Compose up, will take every service that is required. It'll actually pull all of those images from Docker Hub, which will all be the latest version of all of those images that it needs. It will spin up all of those backend services. It'll wire them all together, and it'll then create a fake, it'll create a Postgres database and populate it with some initial data so that the whole thing kind of makes sense on first load. And so that's kind of the easiest way to sort of get going, to sort of get your feet wet on how any of this stuff works. But yeah, from there, like what does everything actually do and how does it actually work? That's where I think sort of listing some of these out is worth noting. And so the backend services is probably the best place to start because it's the stuff that we write the most and or that takes the most time and does the most diverse number of things. As for the actual approach, we've written this all as like a microservice-oriented architecture. If you're not familiar with microservices, that's just basically more servers that do fewer things instead of these big monolithic servers that do lots of things. The reason for that is you can compose them and spin them up in different quantities. And so these servers, when they're actually running in production, we can have, for example, 15 copies of the API server and only 2 copies of the identity server, or vice versa, or whatever is needed to scale the actual, to accommodate any load on the system. And the other reason is it makes it a little easier to understand and componentize and compartmentalize sort of the responsibilities. And so if you want to do anything surrounding identity, you know that you have to talk to the identity service, and you know that all logic surrounding manipulating users or user information is going to happen inside of identity. Yeah, and so that's sort of the general reason for the pattern. The services as we grow may change, and may merge, and may move around, but generally it should always be expected that we can write these services as composable things. It should be totally fine to add new services that do completely new things, and the entire sort of architecture should not in any way buckle under that. So I guess start by listing the service. Anybody questions? Yeah, this is all pretty standard stuff if you're familiar with modern web stacks. But yeah, if not, I'd love to just get into like comments, things between all the services. Okay, cool, we'll do that. So biggest question is like, all of these services here, API, identity, patch bay, task management, Sentry, coverage, and content are all written in Go. They're all stuff that we've written over the last 8 months as a, in service of archiving things, in service of monitoring things that have been archived, all kinds of different tasks. They all surround some sort of web archiving, either creation, storage, or distribution of archives, or analysis of archives. Aside from that general purpose, the services themselves have a whole bunch of things in common. And I've sort of outlined all of those in these sort of header points, which this list looks a little bit gross, but anyways. It's worth noting, this is sort of the stuff that you can expect to see when you see it, when you open up one of these repositories. And the first place to start is always server.go. That's the easiest point to enter. Server.go is where you will find the main function. And so for anybody unfamiliar with the Go language, Go is a type of language that if you're defining a main package, it'll have a function main, and that's the main sort of routine of your package. What's up, Jeff? How you doing? Yeah, and so we're just talking about services. Server.go defines main is the kind of main patterns that you can always open up. Server.go, look at the main function, and you know that's where the program's effectively going to start execution. There's some couple caveats to that. You have an initialization function called init, which runs before main, but generally you can always expect that main is the best place to start when you're trying to understand what the service does. And so let's actually, while we're here, I might as well use a sort of like service as an example. I have to close this, I guess. Sorry, give me 1 second. Sure, let's put it there. Apologies. Save and don't save. All right, so let's use, I've got, these are all of, this is just my data together project. Let's use, why don't we use API as the service that we're going to look at. So I don't know if you can see this very well, but API is sort of the like this. I've opened this folder, and this is what the actual repository has been cloned to look like. And so I'm going to open up this server.go. And so this is the sort of main function. And as I was saying before, you can look at this main function, and basically this is the best place to start understanding the app, just by reading through this function. And I intentionally try to keep them pretty short because I don't want you to be overwhelmed at first. And there's a general idiom that you want to keep the main function fairly naive. But basically, what does this service do? It's going to kick off a connection to a Postgres server. It's going to create a new instance of a server. It's going to attach routes to it. It's going to print any configuration information. It's going to tell you that it's starting, and then it's going to start listing. And that's pretty much what it's going to do. There's lots of other stuff, but in almost all of the files, you'll see this. I've included this note in almost every service. Basically, that we create a new server routes. We also, the reason we use this pattern is I can attach this for testing, and you can actually spin up a server that just has all of these routes attached for testing purposes. But reading through all these, you can sort of see what the app does. Most of them have this like status indicator, these a list of users, primary sources. So this is the actual JSON API. And to understand what some of this stuff does, we can actually sort of cruise through each of these functions and sort of start to unpack what it is from here. Yeah, just quickly going back, config.go is sort of the next major pattern that you'll see a lot. And so each service has a configuration setting that you'll see. This file is almost always called config.go. And basically what config does is you'll see this internal. So in Go, when a definition is lowercase, it means it's internal. So this is an internal configuration for this server. And almost all of them use this datatogether.config package. And what this config package does is a couple of things, but the most important thing it does is this: it connects all of these to environment variables. And the place where that happens is in the init config function, which again, you'll see this in almost every service. This is where we define some like required strings. We determine the path to the package. This is because we often are operating in a containerized environment. So we sort of have to leverage the Go path to understand where we are. But what this does is it takes all of these config variables and it looks at their version, a version of them in all caps snake case in the environment. So for the example of URL root, if there is an environment variable URL root like this, the config package will automatically read it and it will cast it to the proper type. And if it's wrong, it'll sort of print out a console error saying, hey, you said this was going to be a Boolean value and you've made it a whole bunch of a giant string of text. And so if that URL root is present in the environment that it's running in, it'll automatically add that to the configuration and sort of configure the server to work that way, which is great for running in when we were running on Heroku. We would just go into Heroku and define all those environment variables, and it'd be easy peasy. There is one very important caveat. Go often, by convention, uses they'll often have the concept of modes, like server modes, like develop mode or production mode or test mode. And this is specifically to sort of say, hey, you're in test mode, you shouldn't be writing to the production database. And that's sort of a way for developers to keep themselves sane. And that variable is almost always defined under the Golang env variable. So it looks like this, Golang _env. If that's defined, there is one other place that, well, actually, even if that isn't defined, that sort of determines the mode for the whole server. And so if you're in production mode, it'll pick up and run. But we also have another place for, you'll often find when you're running locally, you'll want to have like, be able to quickly switch between different modes if you need, or you'll want to have like a set of stored variables rather than sort of polluting your master environment. It's nice to have a little file that just defines, hey, these are all my environment variables when I'm running in develop mode, or these are all my environment variables when I'm running in production mode or test mode. And so the config package, you can read more about it at this datatogether/config bit, actually supports this other, a special file called .env files, which you'll see this pattern in a lot of different languages. It gets used a lot in the Ruby community, it gets used a lot in the, where else? I've seen it around. But basically, we have this, so my API develop actually have this like folder set up that says, or this file inside, and it's important to notice that this is everything is, we have this special thing in the gitignore that says, don't check this into version control. We don't actually want your .env files in version control. But I can define a file locally called develop.env and put whatever I want in it. And it'll read these as if they're environment variables. If there is an environment variable defined above it, like in the actual environment, it'll use that before the .env version. But this is really helpful for just like, hey, I need everything in one spot, and I can just sort of say Golang _env equals develop, and then I can run the service, and it'll automatically look for a file in my home folder called .develop.env, and it'll load from there. And you'll get a little log notification saying, hey, I'm reading from this .develop.env file. Yeah, it tends to make things a little easier when you're working with configuration. Servers support arbitrary types of configuration, and reading through the actual config is very helpful for understanding what the service itself does. If the service does any kind of remote communication, if it does any, if it supports TLS, which is like HTTPS out of the box, we have that. We have, sometimes we do allowed origins for core support, all kinds of stuff. Like the API service is very public facing, so it has a lot of like public configuration options. And so you can actually configure on the fly for, not on the fly, you can configure before startup with the API server who it'll allow cross-origin requests from, all of that good stuff. And so adding to a configuration of a service is pretty easy. You just add the field here and you can modify how it behaves. And then this gets set to a global variable called CFG, which anybody can use and pass around. Yeah. Okay, I want to keep moving, but feel free to ask questions if you haven't. Beyond that, these are some like general patterns that we see a lot with just as you run-of-the-mill Go sort of like development. We use the Logris package for logging. Logris is like up to like a gajillion stars on GitHub at this point. It's one of the better logging packages because it supports key value pairs in your logging. It'll actually let you log. It supports structured logging, which allows you to say, hey, this user, this request ID, all that kind of stuff. I'm a big fan of this guy named Dave Cheney, who wrote a really decent blog post, in my opinion, on logging. Basically, the sort of boil down of it is we only use log.info and log.debug. Log.info should be stuff that the person running the server can't turn off, like when requests are coming in and when something is fatally failed or anything, stuff that you need to know about the way the service is behaving. And then log.debug should be very verbose and should only be opt-in. So if you're trying to actually debug a process, that should be helpful. I don't use debug a lot because I tend to sort of try and make that work through testing and then call it a day. But if you want to add log.debug, I would not in any way be offended. We vendor everything with GoDep. GoDep is a vendor package, kind of like a package manager for Go. It's often said that one of Go's big fatal flaws is lack of a decent package manager, and I don't disagree with that. So what GoDep does is it just says, let's vendor everything in, and we check it all in version control. And the reason for that is to support the notion of reproducible builds. And so with any data together service, you should be able to rewind its Git history to any point where if the build worked at that point, you should be able to type go build and it'll actually build the whole thing right then and there without any like dependency management problems. And this has to do with like the issue of, later on somebody deletes a package, somebody changes the way a package works, or you import the wrong version of a package at the wrong point in time. It makes sure that always works the way it should. Finally, some basic container. Everything is containerized. We ship to Docker containers. We use Circle CI for testing, and the final step of any passing test that gets pushed to master is an update to the Docker image. So you'll always see if you push and it goes to master and the test pass, you get a new Docker image. And so everybody else running Docker Compose up, as long as they haven't modified the Docker file, it's getting the latest build when they do that, which really helps to sort of keep everybody working disparately in sync, particularly in this sort of microservice-oriented world. It can be a real pain to try and maintain, oh, are you running the latest version of this thing? Are you running the latest version of that thing? It's super frustrating. And so that sort of helps with that whole process. If it makes it a master, we're good. And then, yeah, there's this, some of the more, yeah, this probably should have gone above, but basically we also use this two other major patterns. We use RPC a lot, which stands for remote procedure call, but it's also the name of a package in Go that allows communication between these services. So in a microservice architecture, you need to be able to talk from one service to another. And the way that we do that is with RPC. And the way now you have this very strange problem of, okay, I can ask a service. So RPC is server-to-server communication in this context. And so we run into this problem very quickly of like, if one server asks another server for something, And if you ask the API for that same sort of behavior, we want to make sure that we get the same response every time. And so to get that, meaning you want the behavior to be the same, whether you're talking on the API or over RPC. And so for that, you'll often see this pattern all over the place in the code base. I'm going to hope that it's properly implemented in the API, because if it isn't, I'm going to look like a fool. So let's do collections. So here we have a collections. This is just to do an example of how this works. We have an endpoint called collections, and then we have a middleware. Middleware is just, so basically all middleware does for us is like, it's a very thin wrapper that logs everything out and potentially adds some like specific information in the context of the API server. This means it adds the session user to everything. So you can always get the user out of at any given point if they exist. If not, there's an anonymous user with a session ID added. But if we go look at the collections handler, all the collections handler does is it switches on the method of the request. So if this is a GET request, we're actually trying to list the collections. Cool. Let's go look at the list collections handler. And this basically gives you'll notice that this is actually still quite small. And so the actual handling of the request is done through this new collections list thing. And collections is imported up here. Where's collections? It's defined elsewhere in the same package. But if we look at what collections does, collections is just a sort of a structure that's defined on an integer, which is the thinnest type of structure you can create or a data type that you can create that you can define your own methods on and go. And it has this method called list. And list satisfies the request pattern that I'm talking about here. Basically, what this is you'll see this all over the place. So this same list handler can be registered to an RPC listener, or it can be registered, or it can be used the way that you just saw as an API handler. And so all an API handler does is make this call, this very specific call to the list function, but it wraps it with a JSON response and a JSON request. And so we can control exactly how we fill this out, but the actual list, the actual practice of getting a list of collections, you'll always see this pattern where this param structure is defined, and this defines everything that can modify the return of the request. This is every parameter that it takes. So the only things you can do with lists are decide how it's ordered, limit it, and offset it. And so if you want to do pagination, you have to that's on the API side, and it wraps it for pagination. But all of that comes in through parameters, and then we do the actual work of doing the listing. And then we return that through something called an out parameter, which is basically we assign to the response parameter. And this can work over a remote procedure call via the RPC package, or it can work in the API call. And so the reason to do this is we isolate all of the business logic into this place. And so whether you're talking through a microservice or over the API, you're always getting the same behavior. This also provides a really nice location for testing, and it provides a really solid place to document how to talk through this API, because we now have this set of parameters that you have to satisfy. Does that make sense to everybody? This is kind of a biggie. You'll see this a lot, and it seems really convoluted the first time you see it, and you're like, why would I do it this way? And you start to realize that, okay, if it could be coming from here, it could be coming from here, or it could be a test. Like, it sort of starts to make a lot of sense to try and encapsulate business logic in one spot. So far, so good. That makes sense. It's kind of like one of the last big things. And then, and then we often, almost everywhere, if we're storing data on our service, we try to use the Go data store, which is defined by IPFS, and that's for future proofing, basically. If you want to read about the Go data store, it's here. Yes, Go data store. It's a pretty straight interface, but this is called an interface package, which is basically just a package that only defines a series of behaviors, and then these folders are some of its sort of internal implementations of that interface. But if you look at the data store itself, it's just the definition of an interface, and this is how it works. If you want to put data in something that satisfies the data store, you fill out all these methods: put, get, has, delete, query, and then you have a data store. And so if we want to store stuff in Redis, that'll work. If we want to store stuff in the distributed web, that'll work. If we want to store stuff in an SQL database, we use that SQL package. And so almost all of our sort of like handlers or storage, anything that involves storage or retrieval of data tends to work via a function that accepts a store, which is, you'll see that all over the place. So that's where you're reading from the store. You're getting something from the store. You're listing a collections from the store. And that store is actually defined at the very top here as a global variable, which is the type of store that it is. Okay, I think that's probably a decent pause point. Anybody lost? Anybody confused? Any questions? No. Okay. And I guess from there, I should probably outline what each of these services actually does, and then we could quickly talk about some of the packages that are needed to support that behavior, and then I don't know, we can move on to a proper road mapping discussion. But yeah, I don't know if you guys remember, we used to have this sort of like more obtuse diagram of how all of the services connected. I felt like this might be a faster and easier way to talk about it because you actually don't care about how they're connected together. You just care about what each of them does. So API does what it says on the tin. It's a JSON API. It lets you talk to data as an API. The identity server has everything to do with user session auth. Some of you may know, we accept a whole bunch of different methods for authenticating with the service. You can give it a JSON, you can get a JSON web token. You can work over OAuth. We support OAuth in there for GitHub and other services. You can just straight up sign up with an email address. And this is all to sort of authenticate who you are. One of the main reasons we need that is for any kind of protected service, such as archiving URLs or adding metadata. We want to make sure that while we're not maybe super concerned about knowing about who everybody is, we do want to be able to shut down accounts that are sort of not behaving properly. So that's what identity is. Patchbay is kind of Patchbay is a pretty heavy candidate for being merged into the API service, but basically what Patchbay is just a WebSockets server for talking to the context front end. And the reason for that is we do a lot of things that like support the notion of progress or support the notion of sort of two-way communication, where you'll kick off a collection archival task and you'll say, hey, I want updates on when that archiving happens. And you can do that via long polling over HTTP, but it gets pretty expensive pretty quickly. And so Patchbay is a WebSocket communication, and it manages connections and groups of connections of WebSockets to the front end. And so that's basically all the Patchbay does. It's basically the API, but instead of being JSON, it's all WebSockets. It's very tightly bound to the front end. Every sort of thing that you can do on the context front end has a corresponding action on Patchbay. And so there's a deep dive in there somewhere where at some point where we can talk about how we're actually doing that on either end of the wire, but maybe not today. Task management is quickly becoming one of the more important services that we use. This is sort of the industrial strength version of a lot of the custom crawl work that Jeff and the Boston team are doing, where we need to do like highly parallelized crawling of JSON LD documents or like any kind of sort of arbitrary task. But basically what task management does is it's just this it's a grab bag of any kind of task that we would want to perform. And it just uses the RabbitMQ protocol, which is, or the actual AMQP is the name of the protocol for actually doing task queuing. And so that's one of the services that we rely on as an external service. But AMQP basically just is like a standard way of routing tasks between, or routing queues. So you can create a queue of tasks, and we can spin up any number of task management servers, and they'll just listen on that queue, and they all know how to do every type of task. And so some of those tasks include stuff like, hey, let's go crawl this Sciencebase API. Let's do that heavily in parallel. Or let's go crawl this JSON LD document and create a collection out of it. Or let's go update this collection and check all of its URLs, or anything that isn't sort of crawling in a open-ended context. There's a lot of these little tasks that we've been asked to do a lot. Nowadays, whenever I get asked to do one of those tasks and we try to automate them, I tend to write it as an addition to the task management server. And it's something that will allow us to sort of automate that ad nauseum in the future. Sentry is our crawler. So that's the open-ended crawler that one of its special behavior, which we're hopefully one day will link up with web monitoring on this project. But Sentry has the capacity to repeatedly look at URLs and check for changes. That's one of its big properties that it has over other crawling services. So you can give it a sort of scoping set of URLs and say, hey, just continuously crawl. And if you haven't checked that URL inside of a time period, you should revisit it and you should check to see if its hash has changed. If its hash has changed, you should make a new record of that URL. And so that's what Sentry does. In the future, the work packages that we're working on will mean that Sentry writes proper compatible work files. As it stands right now, Sentry is set up to crawl to S3. And one of the big outstanding PRs is to get it to crawl to IPFS. Coverage is a service to analyze and catalog coverage of different types of URLs or lists of URLs across a number of archival services. We have stuff like Internet Archive support, and it'll go check the Internet Archive to see if it has this URL and what the record for that URL looks like. We use the Memento protocol amongst a bunch of work supporting services to do that, but there are a number of other exotic services that Coverage has a sort of concept of, and it generates these files. Coverage is kind of lagging behind a little bit right now and easily in the biggest need of somebody to sort of champion as a project, because it's one of the most, I think, one of the best areas for Data Together and Edgy to contribute to the notion of what is covered and what isn't covered and how many times it's been covered. That would be really exciting to sort of get that expanded upon. And if anyone wants to jump in on that, let me know. Content is like a super thin service that it's literally, all it does is take content that's on S3 and serve it up in the right way, serving over the right file type and right. If you want to download a PDF from Data Together, this thing, the Coverage service just says, oh, it's a PDF and it lives here. I'll give it to you. But that's basically it.
Is that where, I guess, where IPFS will be swapped out for us? Like, is it at that layer that things will get swapped out when things go decentralized?
Yeah, so many parts of our service, many of these services already talk to IPFS, like all of the task management archival services now archive to IPFS instead of S3. But yes, that is one of the spots. The biggest outstanding one is the Sentry crawler. It needs a PR to switch to archiving to IPFS instead. And we're trying to wait until our work package supports is like finished. And then once it's finished, that'll be a much easier thing to do. Does that make sense? That's kind of a vague answer. The answer is it depends on where you're asking, but a bunch of everything in task management archives to IPFS, everything in Sentry archives to S3. And the hope is to have it not archived to S3 anymore, and instead just always archived to IPFS. That makes sense, Pat? Cool. And then I guess we could quickly breeze through these packages, but they kind of do a lot of what they say. Archivers tools is up at the top because it's the coolest one of them all. It's Morph.io scraping integration, and that's going to let you talk to Morph and then have that interface with all of our tools and tooling. Followed by the two that I'm the most excited about, which are Go implementations of the work and CDXJ specs from the Internet Archive. And then this linked data package, I think, is worth some attention for everybody. We got up to the like 5 linked data specs, and I started to realize that they should just all go in there in one package with sub packages. And so linked data is the implementation for Project Open Data, DCAT, CCAN, ScienceBase, a couple of other. And so basically there's sub packages in there that all support all of those different types of linked data in Go so that you can read to and write from those structures. And eventually my hope is that we could actually form common interfaces for working between different types of linked data in the master package of that. Archive is, almost all of these services import Archive. Archive is like, if you want to know where the definition of a collection is, or the definition of a URL as we spec it out in the model, that's all in Archive. We should really rename that package because it doesn't make any sense anymore. Archive came from back when we were archive.space, and it was like Archive was just like the core. Nowadays, that should be changed to just like core or something like that. But all of the model definitions live in there so that all of these services can import them and they all work the same way. There's tons of tests on the archive package too. Test coverage in there should almost always be at least at 80%, if not higher.
Is there just back to linked data? Are there sub packages for that, or are they all still kind of in like a little mono package?
Yeah, everything is defined as a sub package in the linked data. So each spec gets its own sub package.
So I guess just wondering, like, is there anyone who's like, are there other Go projects that need to get DCAT readers and writers? And is there kind of like, is there a need, or would it be helpful to like have someone go out and like proselytize and essentially try to get others using that we're using? Like, is that a need?
I think that'd be amazing. Some of them are better than others if we look at the DCAT. So each of these gets a nice README. These READMEs are generated just from the Go documentation. But yeah, like getting people to use these would be amazing. I don't know how many people in the world need a Golang DCAT implementation, but it'd be great if people knew that it existed here. And that was one of the dangers of putting it in like a linked data package. And so I think the first thing we need is a decent PR on here that has a better README. But we have DCAT, we have JSON LD, and like basically with each of these, what I do is I go through and I actually read the spec, and then JSON LD is a little gross. That one needs an update, but like DCAT's a better example. So the actual file, like I literally pull the spec into a Golang implementation and then start to outline exactly how it should work and make to-dos for anything where the support for the spec is a little bit off. And then I write a test to make sure that we find a bunch of DCAT files in the wild and make sure that this thing can parse and unparse them. And so there's a couple of things, ongoing tasks that make this stuff better. One is finding files that don't work. And so if you find a DCAT file in the wild that doesn't work properly, getting that to us so that we can make the test pass with that thing is really great. I found a bunch of those in our travels for which one didn't work a bunch, but one of these. Anyways, that letting people know that it exists because it'd be great to have help. But they're actually fairly straightforward to write. But in the future, it'd be amazing to actually go through and like define an interface for working between all of these linked data structures that is hopefully robust enough to make it useful and general enough to make the abstraction clean and nice. But that's going to take some time. Does that help? Cool. Yeah, and there's not much left. I mean, the config package we've talked about a bunch. It just basically manages configuration in reads.env files. SQL util is, we do a ton of setup and teardown of test suites that involve a database. I like to test against a real database because to me, that means that the data actually went in and then it actually came out and that it actually is going to work. And so the SQL util package, you'll see this pattern a lot. There'll be a folder called SQL, and inside it, you'll have a test SQL, then all the insert and update statements. SQL util just automates all of that addition and deletion for testing. The SQL data store package is, we started off as a Postgres project, and we ended up using a lot of IPFS type stuff. And so we needed an implementation of the IPFS data store interface in SQL. It didn't exist, so we wrote one. This is easily our most usable contribution to the world right now until the work in CDXJ stuff is done. Extract href is a quick command line tool that we ended up needing a whole bunch to just pull all the links and deduplicate them and spit out a list. It's just a command line client. That thing's like a one file. Just kind of useful, so we put it here. And then FFI is just this very naive file format identification. It contains a list of 550 possible file type suffixes. So .json, .txt, all those, and it sort of has a guess about what that should look like. And that's in lieu of using a better project like Harvard's FITS to actually identify what the bytes mean from a file. But we've been getting by pretty well actually with that file, that FFI, just hey, this ends in .csv, it's probably a CSV file, and calling it a day. And yeah, and I think that's it. We use IPFS, RabbitMQ. I use Redis a little bit. We use Redis mainly for the pub sub functionality. So task management has this really, if you want a nice study in Go routines, task management is a great place to read. We just finished a way to crawl a tree in parallel while never overwhelming a foreign service with more than any number of requests at a given time. And that all happens in parallel. And then the progress of that is actually reported back through Redis to the front end. So you can actually see the progress of an archiving task as it's happening. And that all makes heavy use of Go's channels and Go routines to do things concurrently. that make sense? Yeah, Pat, what's up? I'm going to stop sharing if that's okay.
Maybe it's a question for after, but is there, I'm just trying to think of other communities that would have extensive experience with I don't know. No, never mind. It's not. I don't think you're looking for help on this thing. But I was just thinking, like, oh, is there any synergy with like the package management communities, like we're building package managers, like I don't know, just the like problem space of like work.
Yeah, I mean, not so much with package management, to be honest, because they're pretty solid on their stuff. I mean, most people who write package managers are like supreme leaders in their communities, and they're very good at what they do. But maybe they would. I mean, I don't know. Promoting some of our like the linked data package, once the work and CDXJs work properly, those would all be useful. The SQL data store, as far as I know, we're the only people. Well, I do know from the protocol people that we're the only ones who have that. It's a pretty specific need, but I think the implementation of that isn't awful. I should take off all the warnings on it that say it's highly experimental because we're using it a whole bunch now. But yeah, I don't know. Some of these packages aren't awful, but a lot of them, a lot of them are sort of like ready. They don't need a ton of work. The work and CDXJ's packages will need some work, but that's about it. Yeah.
And yeah, sorry, when I said help, it's not like just like, I don't know. I often think of like pooling efforts, like whether there's any pieces that are useful between the two communities. Like my understanding is, and it's a resolution. It's a lot of resolving crap.
Yeah.
It's use of DAGs.
Totally agree.
Not my area.
No, but where we do need a ton of help is making sure we have good interoperability. Like because we're writing new code and it isn't super well tested, one of the big challenges is making sure that we're not making some mistake that's breaking other people's systems. So any of that stuff is really important. And that's where just doing as many interop tests as possible is really important. But, yeah. Yeah, so a lot of these, just to give you a feel for where I'm hoping to go next to make a lot of this stuff more understandable and maintainable, is instead of having this like roadmap repository that defines where we're going to go with everything, I think it's easier to actually have the services as themselves define milestones and issues and keep track of it all right there. Because I've been trying to write the like master roadmap and it just keeps falling out of sync and it's too difficult to actually keep the whole thing working. And so instead what I'm going to do is go in on each one. First thing I'm going to do with each service is make sure its README is up to date and how to contribute to it is actually in place. A bunch of those, I don't think any of them have a decent README at this point. I would welcome any help on that if you understand if you sort of crocked what I said here and it sort of makes sense. That would be I'd deeply appreciate any help on the README stuff. And then the next thing is just defining a set of milestones for where, for each service, for where we think we're going to take it. And then making sure that issues exist to support it and just trying to sort of babysit the issue queues for all of these guys and girls, and people. Yeah. I think that's going to be an easier way to actually coordinate development and make sure that the documentation surrounding future next steps is actually accurate and accurate to each repo. Yeah, does that make sense? Does this help give like an insight into the maniacal mountain of code that we have?
I think it's much more clear than the previous roadmap. I think the previous roadmap, I mean, it was clear enough, but this, somehow you look at this and go, oh yeah, this actually makes sense, without having to sort of scratch, think in your head, well, what about this piece connected to that piece? Yeah,
I think I'm glad to hear, because I have a much easier time reading through this personally. And I think it's because I stopped focusing on how stuff's connected and just describe what the stuff is and how it does, what it needs to do. Because the connections, my brain just frizzles out when I try to do it.
So this stuff is running now, and what's your process for rolling out updates? Because you're probably not, pushing the changes out constantly.
No, yeah. Generally, I mean, I'm running a copy of this, like when you're talking about like the production stuff, there's a Kubernetes cluster that is running in the cloud. And so whenever we push any major pull request that gets landed, I just sort of jump in and I have a one-liner to update any service. And what that'll do is it'll automatically just do a rollout. Kubernetes has this incredible rolling restart situation where it'll just spin down services, copies of a service one at a time, and then spin up the new ones. And so you never actually have any downtime, which is really nice. But yeah, we've got a few things to do there. We definitely, like, outstanding. We got to land the changes to the API that support custom crawls and a couple of other bits. But yeah, that's kind of generally how we do the rollouts right now. I'd be totally open to, I think it'd be interesting to think about just like automating the whole thing and being really controlled about adopting something like the Git flow model, where we can work a bunch off of dev, and then every time we merge into master, that's like the really, like, it just automatically pushes into Kubernetes that way. That would mean setting up another set of Docker images for each service, where there's a dev Docker image and a production Docker image, which actually seems like it makes sense anyways. We have this problem all the time where, like, be like, cool, you want to see some cool new changes? Yeah, just you have to edit your Docker Compose file to show it to work with the local stuff, and it's really frustrating. So it might make sense just to use dev. But that is easily like one of the biggest downsides of working in a microservice-oriented architecture, is like keeping the versions of services synchronized, particularly when you want to upgrade, when you want to ship a feature that touches multiple services at the same time. It's just like, wow. So I think eventually over time, it'd be great to sort of like seek out champions for some of these projects. Like, in particular, the coverage services, I think, is the biggest candidate, because it's the thing that we need the most. I have the least sort of bandwidth to attack, and I have like 5 or 7 ideas on how we can move that project forward really quickly. Sentry is going to get its attention soon, because it seems like web monitoring project has a use for it, and us supporting the actual org spec is like the stated goal of this month. So yeah. Anyways, I think that's kind of, it's a pretty, thank you for sitting through what is a very dense discussion of like all of this stuff. But yeah, does anybody have any major questions about this stuff? Is there any burning concerns?
I was just gonna say, it just looks it looks great. It's so, like, you can tell you put a bunch of effort into organizing it, and it's exciting that that'll be the front face for anyone diving in. And I'm excited for this to exist for, like, so people can take an interest without taking their time. So this video, that is.
Yeah, totally. And we should link this in the actual roadmap repo once we're done. But I think it'll be fun. Hopefully this makes it a little easier. But basically, any of these services, if you want to get into it, you want to understand how it works, clone it, pop open server.go, and pop open config.go, and have a look. You'll immediately start to understand what it does and how it does it. And that's kind of should be the rule always. Yeah, cool. I think probably leave it at that, unless, because I think we have, after this, the next conversation to have is, okay, this is where we are. Where are we going? If you have thoughts or concerns on that, I would love GitHub issues that speak to any question or any potentiality you see for any of these services, or for new services that don't yet exist. I think we should post those on the roadmap repo. I love and would welcome anybody's input on any of this stuff. Yeah, and if you meet any people who have an interest in Go, throw them my way. I will throw any number of training hours at them if they're interested, and we'll see if we can't get them attached to what I think is a fun project.
Thanks, Brendan.
Cool. All right, guys. Yeah, go ahead.
Can I jump into another call with you that's not recorded and just ask a question?
Yeah, totally. Yeah. But yeah, I guess from there, is everybody cool? Are we good to end here? Does that make sense? Awesome. Thanks so much, guys. I'm not going to be able to join the community call tonight. Unfortunately, I got dinner with the team. I apologize, but looking forward to it, and say hello to everybody for me. All right. See ya.